This presentation will be describing the materials that make up a DSLR camera. DSLR stands for Digital Single Lens Reflex. Here is an exploded drawing of the DSLR. On the left, it shows the components that make up the body of the camera. There is the outer part that holds everything together. We will go into further detail about how the outside has to accommodate the electronic components of the inside of the camera. On the right is the camera lens. The camera lens is detachable and can be changed depending on what type of photo you want to take. For instance, if you want better zoom, you get a lens that will allow you to view images that are farther from you. The camera is made of many different components. The main ones include the lens, display, body, shutter, and image sensor. The lens is where light enters and it can, as stated previously, be changed. The display is where you see what you're taking a picture of. This is a feature of DSLR cameras that film cameras do not have. The body of the camera holds the different components inside of it. The shutter is a button on top of the camera in which the user has control when they want to capture an image. The shutter speed can also be altered inside from the settings on the camera. Finally, inside the body is the image sensor, which captures light and converts it into an image which is then stored. The overall purpose of the camera is to capture images as the user desires. There's a mirror mechanism in which light is either reflected or light passes through. If light is reflected, it is just displayed on the screen for the user to see. However, if the shutter release is pressed, the light is passed through to the image sensor and captured. This is another difference between DSLR cameras and film cameras. So when light is captured into an image in a DSLR camera, it is stored onto a memory card. However, in film cameras, you need to use film, which is usually made of plastic or gelatin, to capture the image. So when a camera is made, it has to be strong, shock, and heat resistant. There are electronic parts inside of the camera, and it is important that the user does not face shocks when they are using the camera. Some of the testing that cameras endure through the manufacturing process include drop and temperature testing to make sure that they do not break fast when facing certain drops, and they are able to work efficiently in different temperatures. The body of the camera is usually made of polycarbonate, and it is ideal to use this material because of its durability, and finally, polycarbonate is molded to fit the inner parts of the camera. Polycarbonate is a strong and stiff thermoplastic that has high impact resistance at low temperature. It is also an amorphous material. The graph shows the impact strength of the different plastics such as PVC, acrylic, and polycarbonate. Polycarbonate has the highest impact strength of them all. It is ideal because a camera can be dropped multiple times, for example, and a strong material will keep it from breaking and having to be repaired. Here are also some properties of polycarbonate. So different companies choose different materials to make their cameras and the lenses as well. For instance, Canon and Nikon started working to have their lenses made out of fluorite to make the glass stronger. Other glasses that are commonly used include quartz glass, which is a form of silicon dioxide. Glass is used for its optical properties, and in some cases, however, plastics such as plexiglass are being used because it allows for manipulation of the aspherical lens elements. So it's easier to manipulate a plastic than it would be to manipulate something such as glass. Finally, the lenses are coated to minimize flare, and in doing this, it hardens the glass and makes it more durable. And the body of the lens itself is usually made of metal, which is aluminum, titanium steel, or stainless steel, or plastics, typically polycarbonate, such as the body of the camera itself. The shutter is another important component to the camera, which is in front of the image sensor and controls how the image sensor works. So when the button is clicked, the mirror is raised and the shutter is open. The shutter speed and size of the aperture can also be altered depending on the environment. It can let in more light or less light as the user wants. The materials used for the lenses mentioned are silicon dioxide or fluoride. So quartz glass is the crystalline form of silica, which has more of a network than silica glass. It is a hard material with a high melting point. Fluorite, which has an FCC structure, can also be used, and it is a naturally occurring crystalline material. The optical properties of these materials are important. They are considered to have high refractive indices. And this is useful because when light enters objects with such refractive indices, light will be refracted towards the normal of the surface, and this is what is ideal in capturing images. If this isn't the case, it will be refracted away, and you don't want this when you're trying to take a picture. The image sensor is a central part of the camera. It captures light coming in order to create an image. Most cameras nowadays use CMOs, which are complementary metal oxide semiconductors. This type of semiconductor consists of a single layer of silicon. Photons are captured as charged electrons. They are then converted into a voltage value which passes through capacitors and amplifiers. Through CMOs, the processing of each charge is done individually, which can result in high noise, and this can affect the quality of an image. When this is completed, the signal is received and into the memory and read as an image. Semiconductors are good for this because there's a flow of charge due to free electrons and holes. Some improvements that could be made to the camera include making it smaller and more compact. There are smaller cameras that exist, like if you think of a GoPro, but in doing this, you also sacrifice the quality of the images produced. The sensor technology could also be improved. This will improve the ISO settings, and ISO settings are essentially the sensitivity of the sensor to light coming in. Improving the sensor will allow photographers to take better pictures, even when lighting is bad. The shutter speed could also be made to work faster, which can capture better pictures in situations where there is more motion. And finally, it can be improved in terms of the environmental impacts because the body, as we mentioned before, is made of polycarbonate and it is harder to biodegrade. Some companies are working to recycle cameras to keep the plastic from filling up in landfills. So here are the costs of manufacturing for a camera, and most of the price goes towards the silicon that is used for the image sensor. If you were to buy an image sensor alone, it would cost up to from $60 to $100 for a typical camera, but the price of that goes up depending on the quality of the pictures that the camera can take. So if you think about it, the digital camera is better than using film environmentally because it does not have to use film because film is made of plastic, and when film is developed, chemicals are used and released into the air. Most of the effects of creating a camera are heavily seen from the polycarbonate, and it can be recycled, but it never biodegrades. Another problem is with the silicon dioxide, and most of this comes from mining because carbon monoxide is a byproduct. Here's some data from the eco audit. Most of the energy used in manufacturing and towards this and CO2 footprint comes from the polycarbonate. In summary, the main components of the camera are the body, lens, shutter, and image sensor and display. The main materials used to manufacture a camera, this also depends on the manufacturer as well, are polycarbonate, silicon dioxide or fluorite, metal, if applicable for the outside parts, such as we stated for the lens, silicon. And the environmental effects, most of it is attributed to polycarbonate because it is a plastic and it is harder to biodegrade. And here are the resources. If you have any questions, please leave them below. Thank you.